Organizers. So just wanted to start that off. It's been great so far. So let's go ahead and get started here and take you on a wonderful journey. This is a slide deck about a book that I've been writing. It's the Avatar Project. So if y'all are busy, if you guys got things to do, I usually do this as a courtesy if there are other talks you want to see or if you wanted to go grab breakfast or whatever. It's early. This is the Too Long Didn't Read version. Go pick up the book here if you need to set up a virtual lab. It's hosted on a server in my basement that hasn't died yet, so that's awesome. But for the rest of you poor bastards who want to sit in here and listen to me talk, this is me. My name is Tony Robinson. I go by da667 on social media. I've been called Twitter infamous. That's my primary social media. You can find me on there. Feel free to send me messages, ask me questions. I'm more than willing to give you an email address. If any of you want contact information, I also have business cards after the talk's all said and done. Most of my background is in network security monitoring, so flow analysis, NSM, packet capture, IDS and IPS. That's my bread and butter. I do a lot of threat intelligence as well, so pivoting off of passive DNS data, HTTP headers, doing the whole, we found one bad thing, how many other bad things can we map out from that, and all this and that and the other thing. I do a little bit of malware analysis on the side. I am not a reverse engineer by any stretch of the imagination, but I do enjoy blowing things up in dynamic analysis labs, doing the triage, and comparing hashes, all sorts of fun things like that. Some of my greatest accomplishments, I spoke at a number of conferences. I've been all over the place, Hack Miami, ShmooCon Fire Talks, plenty of B-Sides. First B-Sides out in Columbia, I did a talk there. So I've been around the block a time or two. Most of my talks in the past focusing on NSM and fun stories. I've been told I'm a pretty good storyteller. I have quite a few. One of my favorites was when I found a dead drop for data exfiltration by the Operation Cleaver group just by doing Google Wax. Turns out that they left an anonymous FTP server up on a provider, and they left their exfil out there for anybody to grab. And that was a good time. Found that 6 months before the Op Cleaver investigation went live, and Cylance reported on it. So that was a good day. I was at one time classified as a social media threat by ESET. I would post a lot of threat intelligence data. This IP address is hosting this IRC channel. It's using remote file inclusion or shell shock, and here's 500 bots sitting in the channel with screenshots and everything, and ESET apparently didn't like that, So I don't know how to use a computer, obviously, because it took us a hell of a good time to get shit set up here. So that's me in a nutshell. So now that you're here, now that you know about me, what's this project all about? I'm going to regale you with another one of those lovely stories. So this for this book that I've been writing, it isn't my first foray into trying to write a book. I've tried writing books 2 or 3 times and managed to fail for various reasons. Either the ADHD has caught up to me, A's needed killing, various other things have happened. I tried doing a book in the past about setting up a dynamic malware analysis lab, and things just kind of fell off by the wayside. So last year I just said, screw it, I'm going to cast aside a lot of other things that I was working on, conferences and whatnot. I just cast it all aside. I went down to the basement data center of solitude, and I started writing. And right around that time, a little bit afterwards, I was approached by my boss at my current employer, Hurricane Labs, which this is the only plug you'll hear from. I got to give a great amount of thanks to them because they didn't claim this as intellectual property. They're letting me work on this on company time, and the only thing they said is, when it's all done, just make sure we get a free copy of it. So anyhow, my boss is saying we could use training for our SOC analysts, and I was like, I like writing, and they're like, also, we'll give you extra money for it. I was like, I like money too. That's awesome. So it started off as a pretty simple book, and I was figuring, well, if I write it here, they said that they don't care if I share it in other places. This could be something that's beneficial for a lot of people. So I started writing. The lab was very simple. It was just VirtualBox. Here's how you set up pfSense. Here's how you set up Snort or Suricata to bridge virtual networks together. And that was about it. And then it exploded in complexity because I was like, well, I was doing a bunch of what-if scenarios. What are other common hypervisors that you see out there in the wild, for running virtual machines? VirtualBox is what I like to call the least common denominator. Anybody can pick it up and download it. It runs on practically everything from BSD to Windows. Any major x86 operating system will run VirtualBox. But a lot of our guys had VMware Workstation, or some of them were on Macs running Fusion. What about the guys who wanted to set up a lab on ESXi? And then in the middle of all that, I discovered Client Hyper-V as a thing, and has become one of my favorite hosted hypervisors. It's freaking awesome. Just a side note, if any of you aren't Microsoft fanboys, I'm not necessarily a fanboy, but as you can tell by the slide backgrounds and stuff, I like playing video games, so it's my native platform. It's what I always run most of my stuff on. So to have a hypervisor that's integrated with the OS and is free if you have like Education, Enterprise, or Ultimate editions of Windows 8 or Windows 10, that you can just go to Programs and Features and say, yeah, I like that, I'll take that. Have that integrated in with the OS is really nice to discover. And of course, Microsoft, they have all this cool shit and they never advertise it. So word to the wise out there, if you're a student or if you are strung for cash, it's free and easy to set up. So that's just my quick plug for them. In any case, so it started off as, here's a guy to do it on VirtualBox. And that is like, well, here are the 5 hypervisors that I want to cover. Because, in addition to them being the most common hypervisors that we use in our SOC with all of our guys, those are the ones that you're most likely to come across, or the most likely ones you're going to use in most enterprise environments are these hypervisors. Most corporations will say, we're a Hyper-V shop because why the hell not? We have the Windows licensing. Why bother paying for VMware if we're going to just use Hyper-V on our Windows servers and call it good? Or some people drank the VMware Kool-Aid entirely and, all of them run VMware. Or you might be a budget shop or a budget analyst and all you got is VirtualBox and a prayer, YOLO. To make a very long story short, it was initially a tutorial on how to build an IDS and IPS analysis lab. Maybe I was going to do an introduction to Snort or Suricata rule writing later, and it turned into this hulking, massive virtualization book that covers a baseline lab across 5 different hypervisors. So I don't know if I think that might be clear enough for everybody to make out, but I show readers of this book how to build this network diagram. I'm going to take a couple of minutes and explain what's going on here. So this network diagram composes of 4 networks. The different colored areas, a bridge network, one of them is labeled management in the blue. There are 2 that are labeled IPS1 and IPS2. And if you'll notice in the center between those 3 networks closer to the top, there's a pfSense firewall that's acting as a gateway and enforcing traffic or access control between those networks. You might notice in the green network there is a transparent box and a transparent line. This is for the users that elect to set up this lab network on a bare metal hypervisor. That would represent the jump box or the management workstation that you would have to access your VMs from. So, to a lot of people who have some experience in the industry, this is super basic shit, but to a lot of other folks who are trying to get their bearings in information security, these are things that they aren't necessarily introduced to. So I want to make things as clear as humanly possible. The other side here, if you have a hosted hypervisor, that's a physical representation of your workstation on the network and how your VMs are getting out of the network. If you notice in the management network, again, there's another transparent box and a transparent line. I instruct readers on how to make a host-only network adapter that is able to interact with the VMs in the network. In that way, you can take this system on a hosted hypervisor, and it's fully portable. Any place where you have an internet connection and you can bridge, and get internet. The entire lab could be network connected to your physical network, or as mine is right now, I don't even have this connected to the Wi-Fi, and I can guarantee just about everything in the lab is working perfectly fine. Aside from stuff that requires internet access, of course. So this right here is like a big complaint, you see a lot of people say is like, oh shit, I've gone from one network to another, my IP addressing scheme has changed, how do I access my VMs if they're on a bridged network? So in this way, putting them in on this management network and having it host only, the IP address scheme never changes. So it's a really nice way to have a portable lab to where you can demo things really easily to your friends, or do whatever you want to do wherever you're going to be, and have it be extremely portable and easy to set up. So I've beat that into the ground. I have 2 VMs in that management network. One of them is a sim VM that I instruct readers on how to install Splunk. And then there's another VM here, the IPS management interface. And I clarify on that because if you notice over on the 2 IPS networks, there's IPS interface 1 and IPS interface 2. So altogether, there is one VM that has 3 network interfaces. I'll be coming back to that in just a minute. So let's go over here, and you see that there's a Kali Linux VM on one of the IPS networks and a Metasploitable 2 VM on the other networks. Like, this is looking super basic so far. Where's the fun at? Metasploitable 2 is super old. What's the point? Well, I'm getting to that. So we come back to the IPS network interfaces, and you see that pink line that's kind of dotted between the IPS 1 and the IPS 2 networks there. I'm going to instruct readers on how to set up AF packet bridging, which is a special function of both Suricata or Snort, to where you're taking these 2 disparate host-only networks and you're bridging them together. You're using the VM to pass traffic, the Snort VM or the Suricata VM to pass traffic between those 2 networks. So the premise here is you have the Kali VM on one network and you have Metasploitable 2 on the other, and the bridge has to be up in order for anything on these top 3 networks to reach the network at the bottom. If the VM is not up, then that essentially turns into a host-only network. And what that allows you, this is in network terminology, this is a fail-closed network. So not only do you have a nice portable lab network to work with, if there are pieces of malware that you don't want to have internet access, or if you're doing other research and you're doing things you want to make sure it's offline, at a moment's notice, if you just turn this VM off, you have a fail-closed network, you have a host-only network, and at another point, if you need to do network updates, or if you want to do malware analysis and you want to see who this thing is calling back to and who it's talking to, you just bring the VM back up. And I guide readers through setting up Snort and Suricata in bridge mode, have them install a service to where you can turn the VM right off at any point and take it down, and the bridge goes down, and you can turn it back on, and it's a service, and it comes right back up when things brought back up online. It's like virtually zero maintenance for getting that all set up. So that's the long and short of the entire network. I show readers how to build that, and I've reproduced this same network setup across all of these hypervisors. The network that is considered the baseline network. That is like I show people how to do that, and I say from there, if you want to modify it, I give a couple of suggestions. I say you're mostly on your own, but I chose these hypervisors in particular, again, to reiterate, because they're the most common that you're going to encounter out there in the world. And to be further honest, these are the ones that I know. And if I took any more of them, I took any more suggestions, or if I wanted to write more, I would lose my damn mind, because, I've heard people say KVM, I've heard people say Beehive. I say, why isn't Citrix Zen server covered? And to which I said, I'm not making a profit off of this, and I'm only working off of what I know. If you would like to contribute, I am more than welcoming to have you contribute a version of this on KVM, on whatever virtualization platform you want. But I stayed at 5 because this book is close to 600 pages already. So, and a lot of people say, 600 pages, are you fucking crazy? That's like a college semester book. That's like a book you could kill somebody with, man. And to which I said, it was like, The book is interesting because, you know, it covers so many hypervisors. I have it set up kind of in a choose-your-own-adventure format. So the beginning of the book is, here are things that you need to know to get started. You need to understand the command line. You need to understand your TCP/IP. And I talk about the command line. I say you should probably know a little bit of Linux and a little bit of Windows. You should understand the basics of networking. You know, what's a static route? What's DNS? What are all these things? What are common service port numbers? And I say, if you don't know these things, here are free resources to get your bearings. And then I say, I make recommendations for hardware. And, you know, I say that if you want to get started, if you want to be able to build a baseline lab, here are the hardware recommendations I say to get started. Then I say, here's the hypervisor choices, and I say, to choose Hyper-V, go to this page. To choose VirtualBox, go to this page. And the guides lay it out step by step by step with plenty of illustrations. So, you know, what is a 600 page book almost at this point is much smaller if all you're doing is building one lab. So, remember before how I said that this was a basic baseline lab? This is something to get started. What if you wanted to, the best thing about this lab network, the best thing that I love about it is that it's extremely flexible. You can put anything behind that IPS VM that's setting up your bridge. You could turn it into a pen testing network. You could turn it into a malware analysis network. If you're a sysadmin and you wanted to test some configuration management, some group policy, some DevOps stuff, containerization, all of that stuff, you can do all that. This network is both none of these things and at the same time could be any one of these things. And that's how I designed it, you know, to make it easy for any of you to mold it to fit whatever needs you have. So I have a couple of base ideas or a couple of network diagram deviations, and I kind of hint about these towards the end of the book once I say you have the baseline network set up, and now that you have the setup, here's a couple of things that you can think about depending on what specialization and security the reader is most interested in. So one of the examples here might be a pen testing lab. As you can tell, the top three networks here, the bridge, the management, and IPS networks, don't change too terribly much. But the bottom network and the IPS2 network, I create like a little scenario and I say, we set up another firewall in this network. We have one system that has a vulnerable web app. Perhaps you would set it up to where you have to get a web shell on this box and pivot to it and maybe capture network traffic on the web app box to get FTP creds to another server. Learn how to do privilege escalation. You eventually see that you have creds to go to a Windows 7 box, and from there you dump hashes on that box and you find out that you have admin access, and you take those admin credentials and you psexec or do whatever you need to do and you hit the domain controller. So this is super basic example. You know, most pen testers would shred me saying this is some basic shit, but you know, it's one example on how you can take this network and you can mold it to fit your needs. So you'll notice the Metasploitable 2 VM is gone, and I also go over, if you wanted to do something like this and add these additional VMs, here's the resource contention, or here's the resources that you're going to be looking at if you want to do it. So I talk a little bit about hardware and how it changes because you're adding more VMs, right? So that's one variation. And over here we have a NSM or Malware Analysis Lab, which is, again, you see those three networks, not much changes on them, but the IPS interface, we don't have the Kali Linux VM because Kali Linux VMs are for pen testers and people who want to join anonymous. So if we're doing malware analysis, we don't need that. I have a box there that's transparent. Maybe you want to set up a payload VM that you collect your samples on and use that to transit to your analysis VMs in your the lab that's on the fail closed circuit behind the IPS, but that's about it. And then on the other hand, I have a Linux VM here that I label as a minimal Linux VM. Maybe you just want to use that as your payload delivery and your payload grabbing system in order to have that distribute malware to a Linux VM that I named Forensicator. There are guides out there on the internet for setting up a VM with both the Sans Sift and Sans Remnix distributions on a single Ubuntu Linux box. It's real easy to have both of those distributions overlaid over an Ubuntu Linux box, and that might be an idea. You set up a Linux box with all these forensics and malware analysis tools on one side, and then on the other side, you have a Windows box that's just running Windows XP or Windows 7 with, no security whatsoever, maybe your favorite analysis tools, maybe nothing at all. And you execute your malware, and maybe on the IPS VM you're running TCP dump, or you might have Suricata doing additional logging like DNS headers, HTTP headers, SSL certs, flow analysis. Suricata can do all of that stuff natively. So you can, again, this is just another variation, an idea, and a direction you can take the lab. And then the third idea here is, this isn't just a lab for security people to take advantage of. This would be something that if you're a sysadmin or you want to learn better system administration, you want to do configuration management, DevOps, all of that crazy stuff. You might have a box that you have running WSUS, and you might set up a small AD domain and figure out how group policy works. Microsoft has been, in a way, it sucks because things like DreamSpark and TechNet subscriptions have gotten out of reach, but in another way, Microsoft has become more open about offering evaluation license for their software. So it's not totally out of reach to set up a small Windows environment and do group policy experimentation. So you might set up WSUS, you might set up GPOs, you might work with other software management tools like SCCM and figure out how they work. On the opposite side, for Linux, you might work with Salt, Ansible, Chef, Puppets, all of those various config management tools, and get a better understanding of how they work. And at a moment's notice, again, if you don't want to risk any of these tools screwing around with anything on your physical network, all you got to do is turn the bridge off, and it's a self-enclosed network. And again, these are directions you can take it. You don't have to take any of these suggestions. These are just like, well, I got this base network that you told me how to build. Where do I go from here? These are just suggestions on how you can change this and do your variations. So one of the reasons I decided to do this book is on occasion, in addition to being a very prolific shit poster, I tend to dispense out advice. Once in a while when I'm on social media, it's like, if you're new to the industry or if you wanted to get some advice, just reach out to me. And, true to life, a lot of people would say, I'm interested, how can I get a hold of you? I will do, and I'll end up doing conversations over DM or email, whatever the student prefers or whatever the mentee prefers. And I'll say, what kind of a background do you have? What do you know? And where do you want to go? And more often than not, I'd have people from a wide variety of backgrounds, like people who were in military, who are sysadmins who want to transition over to security. And I would have people who are like, I'm still a student, I have no idea what I want to do. And I would try and dispense the advice to help them out. Open security training, the guys at Cybrary next door, like, seriously, go over there and talk to them because Cybrary is freaking awesome. Like, these are free resources that when I was learning this stuff weren't available or weren't easily available, that you had to pay tons of money for, and they're doing it for free. SecurityTube. For God's sake, Iron Geek. What up, though? But I would keep telling them, go to these different places. Here's good books. Here's free resources. Here's resources you might have to pay for, but, as a student, they're a bit more affordable. And I would eventually come to the point, maybe you should learn how to build your own lab as well. And they'd say, how do I do that? And it would always come down to pick some sort of virtualization software, get some hardware, and do it. And now I could say, when they say, how do I build a lab, or what do I do? I could say, point them to that, and it's like, go do this. And it's much easier. It's a way for me to get back to the community in a consistent manner to where, most students can learn to build something complex like this. I wanted to give something back because I came out here and, the founder of this conference, Forgotten, he introduced me to the hackerspace community, introduced me to conferences out here. I learned a lot of stuff when I came out here from my home state of Michigan. So I wanted to give something back to the community at large, and this is my way of doing it. I haven't charged any money for this book. It's still a work in progress. At some point, I'd like to self-publish it because, just like everybody else, I like money. But, if somebody said, I need a copy of your book and I can't afford it, or I'm a student, I'd be like, yeah, sure, here's a copy. I don't care. I want to help out. So that was the end goal, is just to help students learn. Something that I also got a lot of when I was building this is like, why don't you go into using tools from HashiCorp, like Vagrant, Packer, Terraform? Why aren't you doing this in the cloud? Why aren't you doing all of these automation tools? Why aren't you talking about CM to begin with? And show up hands. Have any of you read Zed Shaw's Learn Python the Hard Way? Okay, I see a couple of hands, not very many, but that's another great free resource for learning a scripting language, is Zed Shaw's Learn Python the Hard Way. It's free and it's online, but he has this concept of learning shit the hard way and not doing it the easy way, and pardon my French, but bitching out, And the way that I look at it, and this could be flawed, is if you're using CM and you're using DevOps, you're abstracting out the build process. You're abstracting out the part where you have to know how to size your VMs. You have to know to remove certain pieces of virtual hardware to do isolation properly. You have to know about, you don't get exposed to these things. It gets abstracted out. And I am a proponent of learning things the hard way and learning how to set up your lab the hard way, so that later on, when you learn how to use Vagrant and you learn how to use these config management tools, you have an appreciation for what they do, and you can perhaps troubleshoot them when they go into a burst like a flaming pile and don't work. Perfect example of that is I tried setting up Metasploitable 3 when it first came out, and Rapid7 had it up. It's like, okay, it wants me to use Vagrant and Packer, so I download them. Midway through, the install script it took a flaming pile, and I was just like, I would be left in a VM that was in a half-finished state, and I was like, I have no idea how the fuck to fix this. So again, trying to do things the hard way, or trying to do this the manual method, you're going to learn more about systems administration and how these things interact and how networking works a little bit, and that builds your foundational knowledge, and it looks really good. I've had 3-4 different people say, I've used the Avatar project and I built a lab, and I said that this is what I used when I'm doing this stuff at home, and it's helped them to get jobs, and it's helped them to impress their employers. So, that's not me saying that. That's other people saying, I've used this, and this is how I've used it, and it's been a great boon in helping me to get a job. So, there are some things that I learned along the way. The quickest way to learn that you know nothing is to try and write a book and train others. You think you have such a grand understanding of how these hypervisors work and how everything comes together, and you come to find out that that's not how it works at all. So, in particular, ESXi and Hyper-V, there were a couple of things that I came across that were a bit annoying. Hyper-V in particular, I didn't... For both of these hypervisors, you need to have MAC address spoofing on for AF packet bridging to work properly. And the reason for that is that AF packet makes a one-for-one copy of the packet as it goes across the bridge, doesn't change the MAC address. So the hypervisor will say, you're spoofing that MAC address. That's not your MAC address. Fuck you, I'm dropping this traffic. And you have to say, no, this is working as intended, I promise. And you have to have promiscuous mode on as well. For Hyper-V, this was something that took me 2 weeks to troubleshoot. I've tried flipping every switch, doing every other option, other than the little checkbox that says, turn on MAC address spoofing. And I got redirected through 6 different Microsoft support forums before I found the one where this guy says, take a look at this Blue Coat guide that says to turn on MAC address spoofing to do HA between 2 Blue Coat VMs. I was like, you know what, fuck it, I've tried everything else. Let's click the checkbox and see if this works. And sure enough, I was like, oh, I'm documenting the shit out of this. Because if it tripped me up, it's going to trip all of the other readers up who are trying to do the same thing, right? So, another fun fact that isn't listed on the slide deck, don't try to run Hyper-V VMs on an exFAT partition. So if you have an SSD and you have it formatted as exFAT, it won't work. This was an obscure thing that I had to dig around for. Found something on server 2008 where somebody said, why isn't this working on an SSD drive that I have formatted for exFAT, and they said, no, it won't work on exFAT at all. Has to be NTFS. So, word to the wise, that was something else that also tripped me up. I blew up my lab one day, deleted all my VMs, and rebuilt it, and it still wasn't working. I was like, why the fuck isn't this working? And then I found this one obscure post out there, and it's like, I'll bet you that's the problem. So, in addition to that, I hate Fusion. I hate VMware Fusion, beyond any reasonable doubt. I'm not a fan of Macs. They're Unix. I love Unix. I love Linux systems, but for fuck's sake. When you go to create a VM and the first thing it does, like when you're done creating the VM, it doesn't give you the option like what ISO do you want to boot from. You have to wait until the entire build process is done. It tries booting to booting your VM. It says, hey, there's nothing to fucking boot from. I was like, yeah, I didn't put an installer disk on there. What the hell are you doing? So you have to turn that off, and then you have to say, here's the ISO that you're going to boot from, or here's the disk you're going to boot from to install the OS. And you had to do that every single time. Another fun thing was I mentioned that there's a good amount of static routing and various other network trickery that I do to make sure that this is all self-contained and easy for the user to consume. Every time you turn off either VirtualBox or Fusion on a Mac environment, it deletes the network cards. So you have VBoxNet 1 or VBoxNet whatever or VMNet whatever. You quit out of Fusion or VirtualBox, those interfaces are gone. And it comes back up, the interfaces come up. If you go into the network manager, network manager in Windows, you have virtual interfaces. They just show up there, and you can bind and unbind whatever interfaces, set IP addresses, do what you need to do, and everything's hunky-dory. On OS X, you have to, use ifconfig on the command line, and I had to make scripts to help users rebuild static routes and reset the IP address on build, to make it easy for them. I was like, I put it in the books, like, don't freak out, but every time you reboot, every time you go to patch this, your interfaces are going to disappear, your IP address settings are going to be completely screwed, because this is how OS X does networking. The last couple of things here is the HTML5 interface for ESXi as of like 6.x, 6.5 is really awesome. There were a couple of bugs I ran into along the way, and those bugs as of 6.0 update 3 and 6.5, which are current versions, have mostly been resolved. It was a little buggy, but the HTML5 interface is awesome because in the past, if you wanted to manage an ESXi box, you needed the Windows vSphere client or you needed their vSphere server environment, which costs money. So if you're a Linux person or you like using BSD, you can use any OS you want so long as you have a modern web browser that supports HTML5, and it's great. The last point I have here is I do a lot of guidance on, I have a VM that's in one format. The Metasploitable 2 VM is my guinea pig, and I teach people, I have this one VM in one format, how the hell do I get it to work on this hypervisor? And PowerShell, the Microsoft Virtual Machine Converter, the current version right now is 3.0. It's a tool that can convert VMDKs to VHDX, which is the format that Microsoft uses for their virtual machines. It worked on this ancient, Metasploitable 2 is based on Ubuntu 8.04, so it's ancient, and it worked perfectly fine. Recently, I was at MACCDC on the red team, and one of my buddies gives me a VM that he built in Workstation. I was like, let's see if it works again. There were a couple of things that I had to edit in the VMX file. I had to delete a couple of lines, and it worked perfectly fine. There is the VMware vSphere standalone converter, which is another fine tool that allows you to take your VMs and upload them just fine. Not a problem. So, the main point is that people have questions about how do I convert this VM. I was like, don't worry, I got you covered. So that was something awesome that I came across when I was doing this guide. So I'm going to try and do a quick demo. I'm going to keep this quick because I see the staff back there looking worried, like, oh my God, what time is it? So I'm going to make this relatively fast. So before I get started with this, I'm going to bring up, I'm doing this on client Hyper-V. Again, I'm not necessarily a Microsoft fanboy, but it's pretty awesome. As you can see here, I've got 5 VMs, Metasploitable 2, Kali Linux, the IPS VM is running, pfSense is doing its firewalling thing, which I also teach readers how to build their VM or build their networks and do their firewalling, and then I have the same VM running Splunk. So, real quick proof of concept. Here's the Kali VM. We're going to ping 172.16.6.3, which is the Metasploitable 2 VM's IP address, and we're going to curl it as well. 16.6.3. So they're in the same logical network, but they're on different physical networks. They're different physical network segments, IPS1 and IPS2. They're still in the same /24, but different physical networks that the IPS VM is bridging. So as you can see from this, I don't know how to run the sleep command. I still don't know how to run the sleep command. God damn it. Okay, so you can see that the curl worked. The curl command worked. We can reach it, and you can see this is the Metasploitable 2 web interface. Here's HTML that you got back. And so from the opposite end, I'm going to prove that, you turn off the IPS VM, you turn it off right now, and there's no way for the Metasploitable 2 VM at one address to be able to reach it. Okay, apparently I don't know how to run ping either. Oh, I forgot to put a number there, my bad. Yep. So, you can see that there's no way for this thing to be able to reach out to the VM. The bridge is down. So, again, that's proving that fail-close functionality that's really awesome and offers you that isolation that you want in an environment, or you may or may not want at will. That's the one of the linchpins or one of the unique things about the virtual lab I set up. And then I just started the VM back up. I started it up, and I have Snort running as a service, and in a second or two, I'll give it another 1 or 2 seconds here to let it do its boot process. But wait for it. Let's get rid of the C1 here and just let it do its thing. Or there we go. It's host unreachable now. That's great. And there you go. It takes a minute or two to boot up, but then the bridge comes back up and they can talk to one another. And that's that fail-close operation that I was talking about. So that was the demo in a nutshell. And also as a part of the guide, I say you're going to learn how to throw a series of exploits over at the Metasploitable 2 VM. So we're going to show you that the IDS rules on the VM are running, and that the SIM that we set up, the Splunk that we set up together, it's getting events. I ran these a little bit further in advance, just in case of demo fail, but you can see that we have a series of Snort IDS events here, so we can definitely tell that the IDS is catching stuff on the wire, and it's also logging it over to the Splunk instance. This is something that we all teach the readers how to set up. So that's the environment in a nutshell. That was the quick demo. And these were just a couple of pictures that I put in case the demo failed, to kind of show, here's events in Splunk, here's a shit ton of shells because it's Metasploitable 2, and I just threw a Hail Mary at it. Here's proof that the curl works. And that's more or less it in a nutshell. I have a ton of people to thank, but we're looking like we're a little bit limited on time, so what I'd like you guys to do, if you got questions or if you want to chat, let's go out into the hallway so the next speaker can get set up here. And I would like to thank you all for your time.